కన్ను ఒక్కదాన్ని
Hello, can everybody hear me?
Yes, sir.
Okay. Okay, in that case, let's start the class. You can see my screen?
Yes, sir.
Okay. So today we will be talking about the refraction happening in the atmosphere. Atmospheric refraction. Okay. So what we have around in the atmosphere is air, right? So the medium is air through which we see. Light travels through air, right? And air also has a refractive index. We talked about refractive index a few classes earlier, right? Refractive index.
Yes, sir.
Yes. So I hope you all know what refractive index is because we discussed it earlier. So, yeah. So you might have seen that the usually the refractive index of air is considered to be around 1. It is 1 point something, but it is considered to be around 1. Okay. And the refractive index of vacuum. You know what vacuum is?
Yes, sir.
Not the vacuum cleaner, like the medium in space where there is no air. That is considered as vacuum. So the refractive index of vacuum is 1, like exactly equal to 1. Okay. So now, in case of air, what happens? Refractive index changes sometimes depending upon temperature. Okay. So due to the change in refractive index, we see there we see there are some aberration, or you can say there are some changes in what we see due to the change in refractive index. Okay, for example, I'll give you an example of this. Like, have you seen the air just around fire? If you see around fire, you see that sometimes when we try to look something through the fire, it flickers. This happens, right? If there is an object that we are trying to see through fire, the object seem to flicker. This is because the refractive index of the air around fire changes. So hot air is less dense. Okay. So if the hotter air has slightly lesser refractive index. Okay. So that is why when we try to see something through hot air, that becomes flicker. Okay. So the random flickering or wavering. Wavering means seeing as waves of objects seen through a turbulent stream of hot air. Like sometimes what happens, like let me give you an example. If you go out in a day and you see, like if this is the road, sometimes at the very edge of the road you see the objects, the things start to flicker, right? This happens, right? Like when you see try to see someone, it becomes like very hazy and like it starts flickering. So that happens because the air near this surface, this area, the air is very hot at that time. So due to that, the refractive index at that area of air is less. So that's why it seems to flicker. The objects that we see seem to flicker. Okay. So due to this, so since the physical conditions of the refractive medium are not stationary. The apparent position of the object seen through the hot air fluctuates. Okay. So this is an example of atmospheric refraction. So this is one of the examples of atmospheric refraction. Okay. So what does atmospheric refraction basically mean? Atmospheric refraction is refraction of light by the Earth's atmosphere. Okay. So due to atmospheric refraction, the when we see the stars, they seem to twinkle, right? When you look at the stars, at the stars in the night, whenever we see the stars in the night, we see them as twinkling, right? This is because of atmospheric refraction again. Why this happens? Let me first explain it to you. So like this is, if say this is Earth, and we have our atmosphere is like around the Earth, right? So we are living on the surface of the Earth. So we are living on the surface of the Earth, and the as we go up in the surface, from the surface, the air starts to reduce. Like when we go up towards space, the air becomes lesser and lesser, lesser and lesser, right? So since the amount of air is becoming lesser, the refractive index also starts decreasing as we go up towards the space. So the refractive index of air is highest at the surface level. mm, Refractive index highest. Okay. But as we go up towards space, the refractive index starts decreasing. Okay. So the twinkling of stars is because of this phenomenon. Twinkling of stars. Why do stars twinkle? It is because of this phenomenon. So it is because of atmospheric refraction of starlight. Okay. So what happens when starlight enters the Earth's atmosphere? It undergoes refraction continuously. Okay. Because as I said right now, that there are layers of, just a minute. Yeah. So as I was saying, when starlight enters the Earth's atmosphere, it undergoes refraction continuously. So what happens? Like, let's say this is your star, right? And let's say, mm, yeah, and let's say we are standing here. So the ray of light from the star, and let's say this is the point where Earth's atmosphere begins, right? So the air is less dense here, and it becomes more dense as we go down. Okay. So since the density of air increases as we go down, the refractive index also increases, right? So when the light from the star comes, it gets refracted. So with each layer of air, it gets refracted. For in, let's say, in this layer, it bends just a little. Then when it comes again, it again bends. Then again it again bends, like this. And we see the light that is reaching to us when we are here. Okay. So what we see is only this part, but the actual position of the star will be, so let's say this is the actual position. Actual position is here, but what we are seeing is the star will be here because the lights gets refracted and it bends. And this is the position that we observe, which is called the apparent position. Okay. Is this clear? Is this clear to everyone? Till
Yes,
now,
sir.
any questions? Okay, good. So no questions, right? So the light continuously bends and we see the light that was bending, and we think that this is the we observe this position instead of the actual position. Okay. So due to this, what happens? Uh, we see the flickering of the light, twinkling of stars. Okay, and due to this reason, near the horizon, near the horizon, everyone knows what horizon means, right? Right? Everybody knows what horizon means. Okay? If you don't know, you can look it up later. So near the horizon, when we see no, let this be another example. So this is the apparent, yeah, as I was saying, we don't see the actual position, we see the apparent position of the stars. Okay, so due to this apparent position, the the star is not and also, like, we know that the star is not stationary, and it's also like changes, it's also like moving in the space, right? So due to these, we see we think, we observe them as twinkling. So the stars are very distant as well, since the stars are very distant. We approximate, not approximate, we observe them as point sources of light. Point sources. So due to we observe it due to this reason that we observe them as point sources, and due to the atmospheric refraction, the apparent position of the star also changes. It fluctuates. Okay, and the amount of the light entering through the star, the amount of light from the star that we receive, that we perceive in our eye, that's why it flickers. This is the reason that it sometimes appears brighter and sometimes appear fainter, creating a twinkling effect. Okay, so to summarize this, why do stars twinkle? Because first reason, we perceive the apparent position of stars due to atmospheric refraction. Okay, second point, the stars are very distant. Distant means very far away. So we observe them as point sources of light. Third point, the position of stars and Earth are constantly changing in space. Okay, so since these are the position is also constantly changing the starlights also constantly changes. Starlight means amount of starlight, sorry. The amount of starlight also constantly changes. That let me write it in a better way. The amount of starlight also constantly changes. This creates the twinkling effect because starlight sometimes appear brighter and sometimes faint. Okay, is this clear? Any questions?
No, sir.
Okay. Okay. So I have a question for you, but it's going to be your homework, okay? The question is, we know that we see the twinkling effect only in stars. So why do the planets not mm, not show twinkling effect? So this is your question. Think about it. Take it as your homework. Think about it, and we will discuss it in the next class when we have. Okay. So this is one of the phenomenons, twinkling of stars, that happens due to refraction of light. The other phenomenon is the sunrise and sunset. So um, we actually don't see the actual sunrise and actual sunset. The sunrise that we see is advance. Like we see the sun before it is actually risen, and we see the sun until like after the sunset as well. So it's we can say as advance sunrise and delayed sunset. What does advance sunrise mean? We see the sun before it has actually risen. Okay. And what is delayed sunset? We see the sun even after the sun has actually set. Okay. So if you calculate it, it's about like we get like sun is visible to us for about 2 minutes before the actual sunrise. Okay. And also like about 2 minutes after the actual sunset. Okay. So by what we mean by actual sunrise and actual sunset is, right, like let's say this is the horizon, this is the sun, right? So we see the sun before it crosses the horizon. Let's say this is the horizon, and we see the sun after it crosses the horizon in the sunset. Okay, so why does this happen? It happens because same reason, atmospheric refraction, and we see the apparent position of the sun. Okay, let's say this is Earth, right? And this is Earth's atmosphere. Okay, now let's say we are standing here. So according to this will be the horizon. This will be horizon, right? So during sunset and after, during sunrise and after and sunset, what happens is, like let's say the sun is here. So it's below the horizon. Okay. This is sun. What happens again? The light from the sun that we receive, it gets bent like this. So that's why we are able to see the sun that is even beyond below horizon. And what we are seeing is this apparent position of the sun, which is here. So this is your original position. And this is what we see, apparent position. Why? Because the rays of the sun get bent due to atmospheric refraction. Okay, understood? Is this clear to everyone? Hello?
Yes, sir.
Okay. Another thing is, like when we see, how many of you have actually seen sunset or a sunrise? Nobody? Seriously? Nobody? Okay. You should go and see a sunset or a sunrise. Sunrise might be a bit difficult for you guys because you have to wake up very early to see a sunrise, but sunset is possible to see, right? So if you go and see a sunset, like I don't know where the nearest position which you have. So like go to a place from where you can observe sunset. Okay. So when you try to see the sunset, let's say this is your horizon, you will see that instead of when we see the sun, it doesn't seem like complete round or like complete circle. It shows something like something like this when it is during sunset and sunrise. Okay, so the apparent flattening. Flattening means like the sun becomes an oval instead of a circular structure. Okay, that means flattening. The apparent sun's flattening of sun during sunrise and sunset is also because the same reason. What is the reason? What is the reason? Atmospheric refraction. We just talked about it. Okay. Is this clear?
So,
Yes, sir.
Okay, good. So, so if all of this is clear, we will be discussing a few other things in the next class. Okay. Meanwhile, I will give you a few homework questions. Okay, this is going to be another homework question. So you got 2 questions for your homework. Please solve it, okay? And we will be discussing this in the next class. Any doubts today? Any kind of doubt or anything that you didn't understand or were not able to understand? Anything? Okay, so if there is nothing, we will end the class here. Okay?
Bye, sir.
Bye-bye. Good night, everyone.